Hello and welcome to Otten Math. In this edition, we're going to talk about sequences and series. This is going to be an introduction. So let's talk about sequences and series. A sequence is a function whose domain is a set of consecutive integers. And that domain typically is going to start with 1 and move on in order with one additional unit as long as the sequence goes on. So in this case, we can say the domain is going to be 1, 2, 3, 4, 5. It could be 1, 2, 3, 4, 5, 6. And so those are our inputs, our domain. The values of the range are called the terms of the sequence. Okay, so it's a function whose domain is a set of consecutive integers. So the domain starts with 1 typically, and will be a consecutive integers up until the end of the sequence. And the range is called the terms of the sequence. So those are your outputs. So in this case, we put in 1, we get out 2. We put in 2, we get out 4. We put in 3, we get out 6. We put in 4, we get out 8. We put in 5, and we get out 10. So there is some pattern here that's part of the sequence. And we'll talk about that in just a second. So the terms of the sequence are the outputs, and the domain are the set of inputs that are consecutive integers. An infinite sequence has an infinite number of terms. So there'll be both an infinite number of inputs and an infinite number of outputs. A finite sequence has a finite number of terms. So in this case, we could stop at 5, 1, 2, 3, 4, 5 is our domain, and then we'd only have 5 terms in the sequence. A series, we're moving on, a series is the sum of the terms of a sequence. So first we started with a sequence. We said the sequence was going to be 2, 4, 6, 8, and 10. Okay? So the sequence is just the terms or the values in the range. A series is the sum of those terms that are in the range. Right? So in this case, as in the example, the sum would be 2 plus 4 plus 6 plus 8 plus 10. So that's 6 plus 12 plus 8 is 20 plus 10 is 30. So a series would be, and this particular finite sequence would be 30, and the sequence would just be the terms 2, 4, 6, 8, 10. So part of understanding a series is being able to write the series in shorthand. And in math, we use summation notation to write the series in shorthand. And this is the way that summation notation looks. So summation notation is just the Greek letter sigma, which is this E letter. And the top of the letter is going to be the upper limit of the summation. So that means just the last term or last domain input of the summation. On the bottom left is going to be the index of summation, and the bottom right is going to be the lower limit of summation, or just the first input. And we'll rewrite this in just a second to give you an example. The index of summation can be represented by any letter and doesn't have to begin at 1. So here's the index of summation. Typically, in math, we use I, but it can be any letter. It doesn't matter. And typically, the lower limit of summation will begin at 1, but it doesn't have to. Okay, so let's take an example. I've got my sigma, my sum of all values with the input starting at 1 and ending at 6. So I'm going to end up with 6 terms in my sequence, and I'm going to add those all together. So in just regular English, the way to articulate this value is please provide the sum of the terms or outputs of the sequence which starts with 1, with a domain that starts with 1 and ends with 6. You're going to use the rule 2i to convert the inputs, which are 1 through 6, to outputs. So ultimately what I'm going to get, if I put in 1 for I get 2. And then I'm going to add, if I get 2 for I get 4. If I put in 3 for I get 6. 4 for I get 8. 5 for I get 10. And then my last input is going to be 6. So I end up with 12 as my last term. And now I'm going to add these all together. I get 2 plus 4 is 6, 6 plus 6 is 12, plus 8 is 20, plus 10 is 30, plus 12 is 42. So the answer to this is 42. And this is called summation notation. Now there are 3 special formulas for sequences in series, or for series in this case. One is where you have a sum where you're just adding 1 for each input. The next is when you're adding the value of I for each input. And the last is when you're adding or squaring the value of I for each input. So let's give an example. In this case, let's say that I have the sum of I from 1 to 6. So for every value I put in, I'm always going to get out a 1. So it's going to be 1 plus 1 plus 1 plus 1 plus 1 plus 1, which is equal to 6. So the rule for this case is just n. And in this case, n is equal to 6. And the next series formula, what I do is I plug in I for each value of I, and let's do this again up to 6. So I say I starts with 1, ends with 6. I have 1 plus 2 plus 3 plus 4 plus 5 plus 6 is my last term. That leaves me with 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, plus 11 is 21. Okay, so remember that number 21. There's actually a rule that you can use to simplify this process, and it's n times n plus 1 over 2. So we take the first value, n, which we know is 6, times 6 plus 1, which is 7, and we divide that over 2. 6 times 7 is 42 over 2, which equals 21. And that's the answer that we previously got by just doing the addition. And the reason why we want to know this rule is, well, what happens when this 6 becomes something that's more like, let's say, from 1 to 101. We don't want to add these terms up consecutively because it will take too long. The last formula that we're going to use is when we square the value of I. So again, let's use a value starting with 1, ending with 6. So I have 1 squared, which is 1, 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, and 6 squared, which is 36. And I get 1 plus 4 is 5, plus 9 is 14, plus 16 is 30, plus 25 is 55, plus 36 is 91. Now let's use the rule to see if we can get that right number. And again, the reason why we're using the rule is because if this value of n is great, or a large number, it's much easier to use a rule. So here we have 6 for n, times 7, times 2n, which is 12 plus 1 is 13, divided by 6. So 6 times 7 is 42. 42 times 13, I have to get out my calculator. 42 times 13 is equal to 546. 546 divided by 6 is equal to 91. So again, we have the same value that we get, but we just use this rule to figure it out.